Alright, so there's some recommended alerts. We covered off the defaults. The next thing is the general methodology, and this is kind of the meat of it all. This is how you decide for your particular use case. Should I alert on something? How should I alert on it? What should the alerting value be? Right, that kind of thing. So I'm going to cover 5 basic criteria for deciding on what to alert on, how to alert on it, and the values to choose when you're creating that alert. The first one is, whatever you're deciding to alert on, is there an actual absolute limit? For example, the host down would be an example of an absolute, right? It's either down or it's up, and you don't want it to be down. So that's a very obvious sort of binary alert. There's some less obvious alerts, of course. Let's take an example. Replication lag. Generally, you're not going to want to see replication lag in any replica set, but there are a couple of instances where you might not want to alert as soon as it goes above 0. You can imagine that you've got this very simple graph here, and you have replication lag. You're graphing it out, and normally it bumps along the bottom here at 0. That's your normal operation. Now there might be, let's say, a bulk data load. And during that bulk data load, your primary is ticking along fine, but your secondaries, maybe they're slightly less powerful, maybe they're not quite as capable in terms of, say, I/O, or something similar that might restrict how quickly they can write data. During that 5-minute data load, you may see a replica lag increase, something like that. Recovers quite quickly, goes back down to normal operation. Now, if you were to set an alert, let's say that what it normally peaks out at is roughly 120 seconds. So let's say that's 120. So you think to yourself, I want to set an alert on replication lag. And I'm going to set it to something quite reasonable, I think. Without having looked at this data, I'm going to set it to 100 seconds. Do I ever want my secondaries to be more than 100 seconds behind? Let's say that's an ideological question, and the answer is no, I do not. So I set my alert at 100 seconds. So here's the alert at 100 seconds, and you see there's one spike above, and you think, well, that's not too bad. But imagine instead of this being a once-off event, this data load here, imagine it was actually happening every, say, 3 hours. Not quite the same profile each time. You've now sent off 4 alerts because your 100-second threshold has been breached 4 times, but every single time that alert has arrived, you know what is causing it. You know that it's your data load, you know that your secondaries can't quite keep up with the primaries, and so it's a known issue. So this alert is not doing you any good. In fact, what it's doing is it's creating the enemy of all good alerts. It is creating noise. Noise is bad. And why is that? Well, if you get 4 alerts, and the 4 times, or 400 alerts, or 5,000 alerts, and every single time that you go in and check, you find out that it's because our secondaries aren't quite powerful enough. We do this load every 3 hours, so just ignore that. What about the one time this fires when it's not part of the data load? So let's imagine that for a second. Let's say there's a very large spike up to, say, 400. Right here in the middle. There's no good reason for this. It comes right before the normal data load, and maybe with this happening every 3 hours, there's 8 of these a day. There's 56 of them a week. This makes 57. Maybe the people monitoring this just don't notice it. So instead of it being a nice, obvious alert, hey, something actually out of the ordinary has happened here, something's wrong, you are going to probably miss it. And the reason for that is noise. So how do we cut that down? First of all, you decide, is there an absolute limit? In this case, we thought there was an absolute limit. We thought 100 seconds was a pretty good guess. As it turns out, that is wrong. So instead, we set it to something a little bit more reasonable. We know that we're going to introduce roughly 120 seconds of lag in for our data load, but we expect that to be nice and predictable. So what I'm going to do is basically double that. We're going to say 240 seconds, which happens to be about 4 minutes. Now, if you remember back to our replica set, I think we estimated that we had approximately 30 hours worth of op log. So 240 seconds out of 30 hours, which is basically your window for how much you can lag before you run into serious problems, means that we're still alerting quite early. It is still an early warning system, if you like. We have plenty of time to fix it. We've learned 4 minutes into the 30-hour period that there is a problem, and we have time to correct that. And it's essentially double what we would normally expect to see for our data load. So this sounds like a pretty reasonable absolute limit to set for this particular alert. And by setting it to 240 seconds, you basically avoid that noise issue. And of course, you can segregate your alerts. So you could have, for example, a warning level alert, and that would be set at, say, the 100 seconds. Then you could have a critical alert, and that could be the 240 seconds. You could have different distributions for the warning level versus the critical level, etc., have different filters so that they are actually not lost in the noise. So there are ways around this kind of scenario where you don't want to create too much noise, but they need to be carefully managed. Generally, for alerts, you're going to have more success if you stick to the ones that people actually want to action, that people actually want to resolve. So there you go. So the first thing, is there an absolute limit? If yes, are you going to breach it on a regular basis? Are you going to create noise? And is there some other way that you could segregate this out, or should you set it to a higher level? So having looked to see if there's an absolute limit, the rest will generally apply to just about any alert that you actually do. What is your normal behavior? In the example we just looked at, normal behavior was for every 3 hours for replication lag to spike to 120 seconds. So we adjusted the lag alert to be above that so that it didn't constantly fire and give us false positives. The third criteria then is, what's a worrying level? So if 120 seconds is normal for replication lag, what becomes a worrying level for replication lag? And in our case, when we said what was worrying, we said 240 seconds. And then critically, you may decide, well, I have 30 hours of oplog. If this starts to go beyond an hour, which is a significant percentage, you might decide that that's your replication lag model. So anything over 3600, this might be escalating it up to your management to make them aware of it. Here, you're getting an info warning type message just to say, oh yeah, your 3-hour data load has happened. Worrying. It's gone over 4 minutes. That's not normal operations. We need to alert on that. Then critical, this might be where you escalate. So the key is keep down the false positives, evaluate each alert in sequence, determine where the alerts should be set, and you can use this basic methodology to construct all of your alerts.